Hey everyone, so picture this. You're a senior architect, you're on a new project, the code is almost ready to ship, the pressure is on, and there's this one huge question hanging over everything, a question that can literally make or break your product 5 years from now. So let's get into it. This is it. This is the question, isn't it? And look, it's not just about finding some place to dump a bunch of files. It's about building a foundation, one that's going to scale, save you a ton of money, and honestly, just keep you out of trouble down the road. If you get this wrong now, you're just signing yourself up for a future of headaches and bills that just keep climbing. All right, so here's our mission for today. We're designing the storage for a brand new product, and it's got to handle all sorts of data. Documents that people need all the time, images that users are uploading, and those long-term system archives. Our goal isn't just to store the data, it's to build an intelligent home for it, right from day one. First things first, we have got to get organized. The most basic rule of sane cloud storage is just having a logical structure. Think about it like organizing your garage. You wouldn't just chuck everything into one giant pile and hope for the best, right? And you can see the two paths you can take right here. On the left, you've got the bad way. One giant bucket for everything. It's basically a digital landfill. It's a mess. But on the right, you see the good approach. Multiple buckets, each with a crystal clear purpose. And this isn't just about being tidy. It's way more secure, it's easier to manage, and believe me, it is far more cost-effective. So for our project, we're starting with 3 totally separate buckets. We've got product docs for our main application files, user images for all the customer uploads, and then system archives for things like logs and backups. See, by separating them, we can apply different rules, different permissions, and different storage classes to each one. This right here is the first big step to building a really smart system. Okay, so let's get to the next big idea. Not all data is created equal. Some data you need instantly, like multiple times a day. Other data, you might look at it once a year if you're lucky. Storing all of that in the same high-performance, high-cost place, that's kind of like paying for a penthouse suite to store your winter coats in the middle of summer. It just doesn't make sense. And what you'll see here is that it's all about a trade-off. Standard storage, that's for your hot data. It's super fast, always ready, but yeah, it costs the most. As you move down the list to nearline, coldline, and archive, the cost to just store the data plummets. But the cost and the time it takes to get that data back goes up. The real trick is finding that perfect balance for each type of data you have. So the golden rule is super simple, really. Match the storage class to how often you access the data. For our project, those product docs are hot. People need them all the time, so they belong in standard. But those system archives, man, they're ice cold. They're the perfect candidates for archive storage, where they'll just sit safely and super cheaply until the one day we might actually need them. Now, for the really cool part. What if your storage could actually manage itself? What if it could automatically move data to cheaper and cheaper places as it gets older, all without you lifting a finger? This, my friends, is where the real magic of modern cloud storage happens. We do this with something called a life cycle rule, and it's pretty much what it sounds like. It's a list of instructions you give to your bucket. You can literally say, hey, if a file in here hasn't been touched in 30 days, go ahead and move it to nearline for me. It is the ultimate set it and forget it tool for saving money and keeping things in order. Let's follow a single log file to see how this works. Okay, so it gets created and lands in standard storage so we can analyze it right away. Then after 30 days, boom, our rule kicks in and moves it automatically to nearline. After 90 days, it happens again, this time to cold line. And finally, after a whole year goes by, the system just deletes it. Poof, no human had to do anything. It's just pure cost-saving automation at work. And look, this isn't just some neat trick to save a few bucks. These rules solve some very real and often very expensive business problems. We're talking about things like legal compliance and data governance. Just think about it for a second. You can automatically rotate your logs to keep those costs from spiraling out of control. You can enforce a rule that says all financial records must be kept for exactly 7 years to meet regulations. And you can create rules to automatically delete user data after a set time to comply with privacy laws like GDPR. This isn't just automation for convenience. It's automation as risk management. It's huge. So what rules should you pretty much always have in place? I've put together a little checklist for you. 5 essential policies that I think form the backbone of any really well-architected storage system. All right, first up, this is a critical little housekeeping rule that honestly so many people overlook. Rule number 1, clean up your incomplete multi-part uploads. So You know when a really big file upload fails halfway through? Well, it can leave behind these orphaned bits and pieces of data. They're like digital dust bunnies. You can't see them, but you are absolutely paying to store them. This rule is like an automatic janitor that just sweeps them up after a day or so. Okay, policy number 2. Now, this one's a really big deal for anyone who enables object versioning, to protect yourself from accidentally deleting or overwriting files. Transition older object versions to colder storage. Think about it. If you're keeping multiple versions of a file, you probably only need the most recent one to be instantly available, right? This rule automatically moves all those non-current older versions to cheaper storage. This can save you a ton of money. Policy number 3 kind of takes that same idea about managing versions and just takes it one step further. And that is to delete old, non-current object versions. Look, while keeping some history is smart, you probably don't need to keep every single version of a file forever. This rule lets you say something like, hey, go ahead and delete any non-current versions that are older than, say, 180 days. It's a great way to keep your storage growth from getting out of control. Next up, policy number 4. This is the classic. This is really the core engine for saving money over the long haul. Downgrade the storage class based on object age. This is that classic rule we saw with our log file. It's a simple idea. As data gets older and people access it less, you automatically move it from standard to nearline to cold line. This is probably the single most effective thing you can do to manage your storage bill. And finally, our 5th essential policy. This one is about knowing when it's time to just let go. Automatically delete data that has expired. Some data just has a finite lifespan, old logs, temporary files, or even data you are legally required to get rid of. This rule makes sure that data doesn't just live on forever, costing you money and, more importantly, creating huge compliance risks. So, if there's one thing to take away from all this, it's this. This kind of thinking is what separates good architecture from truly great architecture. Great storage design isn't about how it works on day one. It's about how it performs, how it scales, and how much money it saves you in year 5. And that's really how you build cloud storage that's made to last. So the question I'll leave you with is this. Looking at your own projects, what's the first piece of data that you're going to automate? Thanks for watching.